Okay, great.
So did we already finish all the final exam part 1, final exam part 2, and midterm 3 review, chapter 9, 10, 12. So we complete those package, right?
We're only going to do final exam part 1 today because the other 2 we've already done.
Okay, so just put it
And then the final is going to be Tuesday via Zoom in person while you take it on Newton. Does that make sense?
Okay.
Okay.
How many questions is going to be in the final?
I'm sorry?
How many? Oh, you say 53 questions.
I think so. I can't remember off the top of my head. If you want to.
I wrote it in here, 53 questions, final, last day, May 19, Tuesday.
I guess so. Then that must be what it is. I don't know right now off the top of my head. Okay, so let's get started. So here's the part, question 1. This is like review from old stuff, like chapter 1 stuff. So remember, when considering different sampling methods, so one of the things you need to review is cluster sampling and the different types of sampling. So remember that cluster sampling involves doing simple random sampling and it's selecting a set of groups, right? So you have whatever group is chosen, all the individuals are included. It's like a cluster, okay? So that's what cluster sampling is. It's not n sampling, it's not just simple random, and it's not just stratified, okay? So yeah, any questions on that?
No, you're good.
Okay, good. All right, so then question 2. It says, Timothy wants to estimate the mean number of siblings for each student. He records the number of siblings for each 75 randomly selected students. What's the statistic? So remember, statistic describes the sample, and parameters describe the population. Okay, so in this case, the statistic would be the mean number of siblings because it's describing the sample. It's a characteristic of the sample. Okay, so that's that. And then, so 3. So 3, we have a group of students surveyed about the number of states that they have visited, and the responses are summarized. What's the cumulative relative frequency of students that visited 3 or fewer states? So remember that you have states visited, and then usually it's frequency, and then you have relative frequency, and then you have cumulative relative frequency, which is the sum of the relative frequency and the ones before it, because it's cumulative. So in this case, there's nothing, so it's 10. For this one, states visited 2, we add 25 and 10, and that's 35. And then for 3 states or less, it's 30 plus 25 plus 10, that's 65. And remember, the cumulative relative frequency has to add up to 1 at the end. So when they ask 3 or fewer, they're asking for this number right here because it counts all the ones before it, okay? Okay, so that's, oh yeah, here, this way. All right, so then we have a data set summarized in the frequency table below. The total is 30. What is the missing frequency? So if we know that the total is 30, that means that all these numbers add up to 30, okay? So in order to find the missing piece, we need to add up all of these and then subtract from 30 to get the missing frequency. So we add these up, and that's 27, and then 27 minus, 30 minus 27 is 3. So that would be 3 right here. And then someone last period had a question about relative frequency, so that's why that's there, so don't worry about that. Yeah, so your answer would just be 3. Okay. Alrighty. Let's see here. So question 5. Given the frequency table below, what's the relative frequency? So now we're talking about relative frequency. So remember, to find relative frequency, you need to add up the total frequency. So all the number of numbers is 25. okay? And we take the frequency of each and we divide by the total. So 6 over 25, 4 over 25, 5 over 25, 7 over 25, and 3 over 25. And they want to know the relative frequency of the data value 2. So the relative frequency is 6 over 25. Yeah? Okay. Please feel free to stop me if you have any questions. But a lot of these we've done already. So let's see here. We have a set of data, stem and leaf plot. And remember, stem and leaf, the number of times that it occurs, you have that last digit that many times. So 52 occurs once and twice, right? So 5, 2, 5, 2. And then 47 just occurs once. So remember the stem and leaf plot, it cancels out, it divides the number from last digit, the first digit, when you're talking about 2-digit numbers. Okay. And then that is 6, wait. 6, sorry, I'm going like all backwards. 7, let me go in order. Greg wants to know the mean of his test scores, which are listed below. So then we just basically need to find the average. So we just add them up and divide by the number of numbers. So we add these up, we divide by 5, and we get 85. So pretty straightforward, yeah? Okay. Now this case, you have here, they don't give you just, because the other one, it just gives you it occurs once by just looking. But in this case, they have the value and then they have the frequency. So when you see a case like this, the mean is calculated as value times frequency, the number of times that it occurs. Then you divide by the number of numbers. So, so for example, it would be 9 times 2, because 10 occurs 4 times, 10 times 4. You see what I'm saying? 11 times 1, you know, number, frequency, and so on. And then when you add it all together, you divide by the total number. How did I get the total number? Well, that's just the sum of the frequencies. That means that there's 15 total. So I divide by 15, and that is my X bar, or my mean. Okay? Questions on this?
Could you hold it? Could you hold it just a bit?
Oh, sure.
Because I wanna keep record so I can help my son when he's he's doing his he's gonna have stats pretty soon. So and
Was that in the summer?
he's in high school, yes.
Oh, cool.
Okay. No, yeah. Okay, got it. Thank you.
And then number 9. Okay. So how do we find the median? Remember we list from least to greatest. And if the number of numbers is odd, it's just the middle one. If the amount of numbers is even, we take the average of the 2 middle numbers. That's the shorthand way to do median. So basically we list this in order from least to greatest. Done. And there's a total of, I think, 10. So we just cancel out, right, in pairs until we get to the middle 2. Okay, so the center 2, and then we just take the average. So we take the average of that, and that gives you 24. Okay. So remember, we used I before. If you use I, that whole I thing, if it's a decimal, and if it occurs between the, what in this case it's the 5th and 6th, so it'd be like 5.5 or something. You just take the average of these two, 5 and 6. Okay. Do you need to see this again longer?
No, I do have a quick question though. I mean, you'll probably go over it anyway, but when it's like an odd set of numbers and it's not an even set, how do we add that up?
When it's odd, you don't need to add it up at all. It'll just be straight in the middle. So let's say, for example, you want to find the median of these 5 numbers. They're in order, right? This is an odd number of numbers. So you can just cancel out, and this is the median.
Oh, okay, cool.
Mm-hmm.
So so you divide by the number, bottom number, when there's 2, but there's even numbers.
When there's not when there's even numbers, but the amount of numbers is even.
Oh, I got it. Okay, I got it.
Because
Total. Okay.
in this case, there was 10.
Yes. Okay. Yeah. Okay.
Okay, so down here, if we have this table, should we use the mean or the median? Now, remember, we usually want to use the mean to describe the center. When will we use the median is if we have an outlier, you know, like where you have a value that would kind of skew your data a certain way. So like, let's say for instance, we had like 1,000. Okay, in this case, if 1,000 was part of it, we would use the median, but it's not. So we don't have an outlier. So since we don't have any outliers, we use a mean. Okay? So, yep.
So I'm sorry. So you said there's no outliers, so there's no mean.
No, we use the mean.
Oh, we use
No
the mean. Oh,
outliers, so we use mean. If
okay.
outliers, you use median to describe the center, describe the center, right?
Mm-hmm.
Okay. All right. And then this one is the mode. So it asks you for the mode. So remember, the mode is the number that occurs the most frequently. Okay, so in this case, 11 occurs the most frequently, so that's my mode. Don't these problems seem so much more simple now that we've like done all this other stuff?
Yes.
Oh my gosh, yes.
Can we just make this the final, please? That'd be
It's like,
fantastic.
it feels like I don't know. It's like it feels like a joke. Like I'm just messing, but no, it's you guys have learned a lot this semester.
Yeah.
Have gone through a lot, so it's really good.
Oh yeah.
Really good to see that, you know. Okay, so in this case, we want the 50th percentile for 60 college courses. So remember that the 50th percentile is AKA the median, right? Because it's the data point that splits the data into 50%, right? It's 50% of this is either below me or above me, you know, including me, okay? So since there's 60 total, a shortcut is to say, okay, I know that this is an even number, so I need the two numbers that are in the middle, right? So I'm gonna use this one and this one because these two, the 30th and the 31st, are the ones that have the same amount of numbers on both sides. So these are the two middle data points because it's even. So now you just need to take the average of these two. And because they're both 57, it's 57. So that's it. So your median is 57. Okay. Any questions on this? No? Okay.
You're good.
Okay, good. All right, and that's it for that. And then 13. Okay, so then we do a 5-number summary where they give you the value and the frequency. So we need to go to our calculators and we can do, or we can do it by hand, but it's so much easier if you use your calculator, yeah? So let's go ahead and do this. So clear this. So we do stat, edit. We have L1 and L2. Okay, so L1 is 2, 3, I'm sorry, 3, 5, 6, 7, 8, and then 11. And then L2 is just 3, 2, 1, 3, 1, 2, 3. So once you enter into L1 and L2, you go to first variable stats. So that would be stat and then calculate. So you would do stat and then calculate and then hit first variable stats. Okay, or one variable stats. So your list is L1 and the frequency is literally L2, and then you calculate this. Okay, and that gives you all this data like the sample, sigma, right? But all we care about is this. Okay, this is the 5-number summary. So we have minimum, Q1, median, Q3, and the max. Okay, and the one that matches this is right here, B. Okay. Scroll down. cool. Any questions on this one?
Those are easy.
Yeah, these are nice, right? Like these nice? Okay, then 14. I know you're gonna be like, what? Is this ridiculous? I know. So the 5-number summary is given to you, and then it asks you for the interquartile range. Remember, that's IQR. And then for this one, you need to remember that IQR is Q3 minus Q1, and that's it. So you just basically take Q3 minus Q1, boom, 7. That's your answer. Okay, let me know if you need me to slow down, I will. Okay, so then 15, it says here, district manager of a retail store keeps tracks of the number of sales, which of the stores represented by these histograms has the smallest standard deviation. So remember that the way a histogram works, right? And the empirical rule, if it's like 95% is within 2 standard deviations. So if the standard deviation is smaller, your data is going to be more concentrated, and your graph will be more thin. Like, it'll be like this. Like, let's say you start out with this, but then your sigma got smaller, your standard deviation got smaller, then your graph is going to get more skinny. Okay? So which one of these is the thinnest one? So you have this one, you have this one. I'm sorry, I know I already showed the answer, but you see how you can compare to all 4? This one is wide, wider. B is really the most narrow. So this is smallest, right? Standard deviation. Okay. So then this one, you have here, Caitlin took both the SAT and ACT exam. Her scores on both exams are shown in the table, as well as the nationals mean and standard deviations. So then they want the z-scores for both. So here's the formula for z-score. And the z-score for the SAT would be x, which is 1850, minus the mean, divide by the standard deviation, and that's all this, and that's 1.4. And then the ACT is x minus the mean, and then you divide by 4.8, and that's this one. Okay, so 1.4 and 1.5. Yep, that's pretty much it. It's really pretty straightforward if you know the right formula. Okay. Any questions on this? No?
You're good.
All right. 17. 5% adults participate in at least 30 minutes of exercise each day. That's pretty. That's a pretty low percentage. I was just telling somebody that I'm not in this. I need to get more exercise. I have no excuse. I have things like, I have an elliptical. I have things I could do at my house. I just don't do it. I don't know what's wrong with me. It's kind of like hard to break that habit, Okay, so how likely is it that a randomly chosen adult will exercise 30 minutes each day? So then we say, okay, 5% is 0.05, right? 5%. So that's 0.05. So on the interval, you have 0, you have 1. This is 50%. So 0.05 is like way back here, right? So it's very close to 0, so it's unlikely. I don't know. I'd like to think that we all get a lot of exercise every day, but it's kind of hard to when you're stuck at home. All right. So here, the general election is today, and volunteers are organizing the ballots. Depending on the part of city in which a citizen lives, he or she receives a different ballot. So you have 2 types of ballots. You have red, and then you have blue. The red ones are numbered 1, 2, 3, 4, and the blues are numbered 1 and 2. So R could be the event you draw red, B is the event you draw blue, E is even, and O is odd. So drawing a blue 2 would fall into which one of these categories? And then it says select all correct answers. So basically, when you draw blue 2, it's the intersection of B and E. Okay. So it would be in the set that does not contain R, right? So if it's not R, it's blue, right? So blue 2 is part of that, okay? It wouldn't be in here because here has to be R and odd, red and odd. It wouldn't be B prime because that would be not B. And if it was B and O, well, this is B and E, so no. And same reasoning, R and E, so it's neither R and it's neither, and well, it's neither R. This is the only case where it could be part of it because of the fact that it's an OR. So remember, B or O means the union of all blue and the odds. So meaning that the whole entire set of blue ballots will be in here, plus any ballots that are odd. So the red ballot 1 and the red ballot 3 would be in this group, okay? But all we care about is what part is the blue 2 a part of, and it is part of the blue. Okay, so these are the two events these are the two things that qualify. Okay. Any questions on this?
So it would just be A and C.
Yeah, it should just be A and C. All right, that was 18, and then 19, here we go. Okay, so W is the event that a randomly chosen person drinks 64 ounces of water a day. V is the event that the person has varicose veins. Wow, that's pretty, okay. So given that the person drinks 64 ounces of water per day, the probability that a randomly chosen person has varicose veins. So we need to find the probability that a randomly chosen person has varicose veins given that this. Okay, so this is the way that it works. If you have the probability of A given B, this is what you're looking for. This is the probability that we're interested in, and this is a condition. B is the condition. So usually it's red, probability of A given B, okay? But in this case, the given statement comes first. So they're trying to trick you. So they give you the condition first, and then they say, hey, what's the probability of that? So that's why B goes first, and then the condition, okay, because of the word given. Okay. Yep. And then this one for the contingency table, they gave us everything except these 4. So we needed to make sure that we remember the way the contingency table behaves. These 2 have to add up to this one. These 2 add up to this one. The columns add up, right? Top to the bottom, and then the rows also add up, okay? So if we're given 102 and this is 145, we can subtract and get 143, right? Because 145 minus 102 is 43. And then here, same reasoning, because we have 102 minus 66, that gives us 36, okay? And then once you have this, you can also go this way. You can say, okay, 93, the total minus one of them. So this equals 93 minus 66. So that's 27. So now we have that. And then this one finally, we could do 36. 52 minus 36 is 16. Okay? And the way we can check if we did it correctly, we add these up and they should all add and work correctly. So 16 plus 27 is 43 and we're good. Okay? Any questions on this?
Can you just wait?
Sure.
So the answer for this is what, 16, 66, and 43, right?
It's 36, 16, 27, and 43.
Oh, 36, 16, and 43?
27 and 43, yeah.
Oh, 27, 43. Okay, got it. Mm-hmm. Thank you.
Sure, no problem. Okay, so that's then 21. Okay, so we have here the probability that a college graduate is offered a job at a particular company given that they also completed an internship is 6 out of 13. Then if we know that 29 college graduates and 13 previous interns were offered jobs with the company, let's fill in the Venn diagram. Okay, so A represents college graduates, so 29. B represents the previous interns, B. And then we're interested in finding the intersection, because if we know the intersection, we know that this space is just A minus the intersection, and this will be B minus the intersection. So then, remember, we're given the probability that a college graduate's offered a job, given they also completed an internship, is 6 over 13. So this is what we're given. Then remembering the formula, probability of A given B is the same as the intersection occurring, probability of the intersection over probability of B. Okay? So, so basically that's like saying, okay, the total sample space is going to be, of the intersection is 6, right? So you have 6, okay? And then you have, so if this is 6, then we can tell that 29 minus 6 is 23, and 13 minus 6 is 17. This looks like weird. So that looks like, okay, yeah. So then that's 6, okay? So those are your 3, 1, 2, 3. Do you guys need to see that more?
From where are you getting the 7?
Where did I get the 7?
Yeah.
So 13 minus 6 is 7.
Oh, okay.
So if entered on a computer, because I see the 3 squares on the side on the left, it would be entered as the top number is 23, the middle number 6, and the bottom number 7.
Yeah, I think it should tell you, like, it should have like a little 1, 2, 3 thing, you know? And then it
So
should have,
the answer is 23, 6, and 7.
yeah, it goes 23, 6, and
Yeah,
7.
because in the papers they're not very clear.
Yeah, so I think in the actual screen it's a little more clear.
Okay, great, thank you.
Yeah. Okay, so 22 says, given the following information about A, B, and C. So we have here, they have these probabilities, and then we have conditional probabilities. The only one really of interest is P given A. Now remember, P of B given A, same formula, probability of B given A, B and A, the intersection, and P of A over P of A. P of A is 0.62. So the only way that this could be 0 is if the numerator is 0. You get me? So 0 divided by anything is still 0. So what we can conclude by this is that P of B and A is equal to 0. Okay? So that means that A and B are mutually exclusive. Okay? So they're mutually exclusive. So we know that A is correct. But this is wrong, and this is wrong because this is not even true, and that's also wrong. So it has to be A. Good. Any questions on this?
Nope.
Move on.
Move on. Let's do this. 23. Okay, so for this one, they give you the X and the probability of X occurring. Okay, so then we have here, how many times did you review your final exam before handing it in? And then we have a probability density function, and it wants us to find the standard deviation. So you could do it this way, you know, where you do the chart and then you find this and you plug it in. It's a lot, right? Or you can just go ahead and plug this into L1 and L2 and do first one variable stats again, and it will give you the standard deviation of X, okay? So I'll show you what I mean. Let's see here. Okay, so stat edit. We have our L1, our L2. So 1, 2, 7. And then we have 1/5, 2/5 of the time, and 2/5 of the time. Okay, so then we go here, we go stat, calculate one variable stats, Okay, so we do L1 and L2 and we hit calculate, it'll give us this sigma of x, okay? So that's it, that's our standard deviation. So
Would it have to be entered as a decimal, or can it be entered as like literally 1 divided by 5, 2 divided by 5?
When I enter it this way, it becomes a decimal. I don't know about yours. I'm pretty sure you could still enter.
Oh, okay, okay.
Yeah, you should be able to enter it also. So then, yeah, so that's it. It's a lot easier than doing the whole blah, blah, blah. Okay. So now this one, it asks for expected value or expected payout, right? And that's the same thing. Remember, expected payout or expected value is the sum of the amount times the probability of each occurring, okay? So you have here 150 times 1.61, that gives me 24.15. 2,800 times 0.03 is 84. 105,000 times 0.0006 is 63, and then we add these three together, and that gives you 171.15. However, it says to the nearest dollar, so that rounds to 171. So your answer is just 171. Okay, do you have any questions on this one?
You're good.
All right, so then 25. Oh, I see here. So this is the one where they give you a whole list of possible probability density functions, and then you have to select all the correct answers. So the next page has like an entire list. So see here. So the first one, you have to add them all up. Remember, what's the conditions? So the two conditions are, they all add up to 1. All the probabilities add up to 1. Let's say sum of p of x is equal to 1. And then the other condition is that p of x has to be between 1 and 0. Can't be negative, so not negative. Okay, so then we did that. So A was good, and then B also adds up to 1. So this equals 1. The sum equals 1, so B is another one. C isn't because it's greater than 1. It's too large. And then D adds up to 1, so then that's 1. And then E is too large. It adds up to something greater than 1, so no. And then F has a negative, so no as well. So the only ones are A, B, and D. Any questions?
You're good.
All right, so that was 25. 26. 26, I have here, identify the parameter P in the following binomial distribution scenario. The probability of buying a movie ticket with a popcorn coupon is 0.711, and without a popcorn coupon is 0.289. If you buy 21 movie tickets, we want to know the probability that more of the tickets have, more than 14 have popcorn coupons, but they just want to know the parameter P, okay? If it's a binomial distribution, P represents successes, right? The probability of successes. So then that means P is 0.711, that's it. That's all that is. This one's a nice one, right? Okay, and then for 27, it has here the random variable X has a uniform distribution. Okay, so it's distributed uniformly with these values between 14 and 20. So that means that A is equal to 14 and B is equal to 20. Now, what's the standard deviation? So the standard deviation for uniform distribution has a specific formula, and that's square root of, and then B minus A squared over 12. So then that's basically like this. So you can just do 20 minus 14 over square root of 12. So you could just enter this in your calculator and you'll get the answer. But if I did some like reducing, but I really didn't need to because it says 1,000th. So if you just, I'm sorry?
I'm sorry. No.
Oh no, it's okay. If you just could just plug in your calculator 6 over square root of 12, and it'll give you this 0.1732 because it says that it wants a decimal to the 1,000th. Did that make sense?
What is I'm copying it. This before the answer, the final answer, it's
What's this?
1/2 equals, what is that other
Oh,
number?
this is times.
Oh, it's
So
time.
this is just, I reduced this. So if you do what's called rationalizing the denominator, you multiply top and bottom by square root of 12. So on the top, you'll get 6 square root of 12 over just 12. So this reduces to 1/2. This square root of 12 is 2 root 3 if you reduce that. So then 1/2 of 2 is 1. That just cancels out. So you're left with root 3, but root 3 is just 1.732.
How would you know?
So this was like extra. We didn't need to do all of this because they wanted a decimal.
Okay.
Yeah, so that's 27. Okay.
Why did you have a line under the 2
Where?
on the standard deviation equals 1.732?
Oh,
Why was there
because this
a
is
line?
the 1,000th place.
Oh, okay. I was wondering what that was. Okay.
Yeah. Okay, and then 28. We have here these distributions and what is true if you have these. So let's first notice that their midpoints are both occurring at the same place. Like this line right here cuts them both in half, right? They have the same kind of like, they're both symmetric about this point. So that means that their means are the same. They have the same mean, okay? And then also one is wider than the other, so that means their standard deviation is larger. So the centers are at the same place means the means are equal. And then A is wider, so larger standard deviation. Okay. So that's pretty much it. And that means that everything else will just be wrong. So this is it. Any questions on this? Okay. Then 29 says, okay, so there's 2 ways of looking at this. So that's why I did this. So Alice was told that her reading score was 1 standard deviation below the mean. Okay, so when you say 1 standard deviation below the mean, when you say that like this, in this way, that's just basically saying that the test score is going to be the mean minus 1 standard deviation. Okay? See what I mean? See what I mean? Okay. So test scores were approximately normal. What is Alice's score? Because hers is 1 standard deviation below, it's really just the mean minus 4. So 86 minus 4, and that's 82. Does that make sense?
Yes.
Okay.
Yeah, it makes sense.
So that's like the easy way to think about it, like using logic. The other way is you use the z-score formula and use the fact that when you say 1 standard deviation below the mean, that means that z is -1, and then you do some algebra and you get back to 82 anyways. So there's 2 ways to do this, you know?
Mm-hmm.
Okay. Okay, so then 30 says, suppose speeds of vehicle have an unknown distribution with mean 63 and standard deviation 4 miles per hour. So a sample of size N44 is randomly taken and the mean is taken. Now let's use central limit theorem for means. So remember, central limit theorem for means says that the standard deviation of the means for the sample mean distribution is the original standard deviation, right, of the whatever the first thing was, and then divide by square root of n. Okay, and also it's the mean is the same as the population mean. So, okay, so then we have here the original standard deviation 4. So we have that sigma is 4. And we also have that n is 44. So we just plug it in. Pretty straightforward. So 4 over square root of 44. And that becomes approximately 6.60. So that's 60 right here. Any questions on this?
No. Very good.
Just a second, please. Just a second.
Oh, sure.
Okay, I'm fine. Thank you.
Okay, then 31. So it's the same kind of thing because you have the average American city has 50 buses, so the average is 50 with a standard deviation of 5 buses. So just from that, you have standard deviation is 5. So city planners interested in the sample mean for a sample of 30 cities. Okay, so then he calculates this and this. But remember, if we know the central limit theorem for the means, we just said that, the mean for the sampling distribution is the same as the original. And then the standard deviation for the sample means is the original standard deviation over square root of n. So this is correct right here, but this is wrong. Okay, so he did this wrong. So what he should have done is he had the mu wrong, but he calculated standard deviation sigma correctly, and he should have had that the mu is 50. Okay. So mu of x bar is 50, and then the sigma of x bar should be 0.91. All right, cool. And I guess that's it. Wow, okay. That's all I have. Do you guys have any questions?
For sure.
Yeah, that's all I have. See, now it's just the answer key.
Okay, so don't want any more surprises.
No, not really any surprises. The answer key part 2 is really, if you look at it, it's the same exact thing as your midterm review.
Yes, yes.
So one went over last week, right? The 9,
Yeah.
9/11.
So I mean,
Okay.
yeah. So it's like, why am I going to waste your time? You know, like we already went through that pretty much.
Still double keying, I was wondering why.
Mm-hmm. When is the final?
Tuesday.
Tuesday. Yeah.
Tuesday.
We
Got
did
it.
Tuesday, right? Tuesday?
Yeah, Tuesday the 19th, right? Yeah, 19th.
Tuesday the 19th during class. So we're going to log in together on Zoom, and then you guys are going to go ahead and go on to Canvas with me on Zoom. That way, if you have any questions during the final, just go ahead and chat me in the chat.
Okay.
Um,
Professor, I'm so worried for the final.
you're worried?
Yeah,
Why?
made me nervous. All final made me nervous. Yeah.
It's fine. You did all the work already. This is like, you got to think about this as your victory lap. So what I wouldn't say, okay, so a cheat sheet, and that's a good question. So in regards to cheat sheet, what you can do is you use all the formulas. So just write a piece of paper with all the formulas that you need, and like what distribution, you know, this uniform distribution uses this, you know what I mean? This is the central limit theorem formulas. There are this kind of formulas, okay? So that's what I would do if I were you. And then that you can keep on hand. Because if you're gonna use your notes, it's gonna be too much, like it's too much. You don't have enough time. You need to just have your the formula is in front of you. Okay, so just have them ready and know when to use them, and then you'll be fine.
How long are we gonna have to do the final together?
We'll have class time. So what is that, 2.5 hours, I think, or 2 hours?
Okay, good.
What?
Also, we can use all this package, right? The final exam.
Yeah, we can't use the package, just use the formulas.
Okay.
So that's what we need to study. We need to make sure we can solve these without having the answer.
Any another study guide that we can use?
No, this is all that we have. So I mean, I don't know. You mean what? I don't understand your question. You want another study guide?
I know, just asking you if you have any another study guides.
Oh,
Finals are tough exams.
yeah. I have other study guides, but I mean, they're pretty much similar to this.
Okay. Okie stories at the same time on 11 a.m.
Yeah, 11 a.m. Yep.
Until what time?
Until we end class, which is what, 1 or 1 something, right?
1:20.
1:20? Yeah. Yeah.
Tuesday. Oh, okay. One more thing. When we can see the grades, the final grades.
It will just be it'll be like about a week after the final or so.
Okay.
I don't know how many questions exactly. I think there are like 50 something questions.
You say 53. That's what you said. 53. I wrote it in here.
Okay, yeah.
We're good with the number you said for.
Yeah, I mean, I don't know where I got that number from. Who knows? I mean, that could be the number of questions on the final. Who knows? I don't know. I won't know until I see it myself. I have to review it. But basically, if you stick to the 2 reviews, you should be good.
Okay.
Okay. Also, you're gonna fix those grades, right? My grades, my homework.
Yeah, I'll go through and look at it. I mean, I'm pretty sure I'm gonna see what.
My paperwork is there. The thing is, they're unable to open it.
So if I can't open it, so why don't you just go ahead and convert the files and repost them? That way no one can.
Okay, okay, I can do that. No problem. It's fine.
Perfect.
Yeah.
Okay, amazing. Okay, well, if there's nothing else, you're free to go and enjoy the rest of your day. And anybody that has more questions for me, I will stick around.
Professor, I resended one homework that this person say 0 because they were unable to already resend it in PDF file. So that one is ready to grade it again.
Oh, I don't know. He's not grading right now. So I don't know. I mean, we have to look at it. You have to give us time.
Okay, I emailed you yesterday.
Yeah,
I don't know. It's not like, you know what I mean?
Okay.
Tuesday at 11 a.m.
Yeah, just be patient because I have 7 courses currently and they're all in finals and everybody has a million questions and everyone's turning in grades. So, you know, if I don't get back to you like right away or if I don't do what you asked me right away, it's nothing personal. Just know that it's because there's like so much going on. So please be patient.
The bottom line is she's busy, guys, and she has a lot to get through. So it's okay. Just be patient. Like, I know you guys are worried. I'm worried too, but we will be fine. As long as you guys are doing your stuff, you will be fine. If you haven't done anything, you should be very worried. But if you have, then you're fine.
Yeah, thank you. Yes, exactly. That's pretty funny. Yeah, pretty much. That's pretty much it.
Okay.
Thank you. Can I stay around with you just to chat for a few minutes? Okay.
Yes, I see a question about the in-class assignments. That's basically the bookwork that I've assigned. They're the same thing. The in-class assignments are part of the grade. Okay, yeah, see you guys on Tuesday. Very excited. Sorry, I can't throw you a party. I usually try to. A virtual party.
Can I ask you a question?
Yeah, go ahead.
For example, for chapter 1, for the book assignment, I
Uh-huh.
submitted the wrong file. However, when I got the I think it was I guess it was a notification in Canvas. I submitted like and I sent you an email or a message to you in Canvas. So I'm not sure if you can see it and correct my grade.
Yeah, I'll go through and take care of everyone's. If you've reposted them, so I'm gonna give you guys some time to repost whatever's missing, and then I'll
Ooh, you guys are good.
I'll update grades.
Awesome.
Yeah. Any other questions?
No,
Just make sure you get everything in, okay? And like, make sure you just keep track. Like whatever you turn in for that whatever you're submitting, that it's consistent with whatever assignment it is. Because some people are turning in like chapter 2 into chapter 4 and chapter 6. You know what I mean? So just make sure that it's consistent, or else you won't get credit.
What do you mean, like
Like
if,
in this book, like in the homework assignment that says like book 4, for instance, some people have put in like book 2 work.
oh, okay.
So make sure that you guys put in everything that is correct with the date. So the Newton thing, I'm gonna go ahead and email my Newton person right now, because I changed the dates. I don't understand why that's still happening. So I'm gonna do that right now.
But when the homeworks due, the old Newton, when I still need to work chapter 12 is my last chapter.
Yeah.
When is the due date for all this?
Tuesday is the last date. I wouldn't wait till Tuesday to do it though.
No, I'm working little by little. So today I'm gonna do more, tomorrow, like that.
Okay, cool. So any other questions?
yes, one more. You said that all the book chapters and all that, and the last day to submit homework was on Tuesday. However, that person gave me a 0 in chapter 10 of the book, chapter 11.
Oh, that's just, okay, so those zeros will just they're just to like remind you to turn it in. So those
Cool.
zeros are like reminder zeros, okay? So you need to see that as like a warning, like, hello, I need to turn this in, because if I just wait till Tuesday, everybody's gonna be turning in everything on Tuesday, and then they're gonna get, you know what I mean? So if you start seeing zeros, that's just because you owe something, I don't have it yet, and you need to turn it in.
Okay.
Cool.
If we resubmitted after getting a 0 for him not being able to open it, you get a notification that you submitted again, so you can see it.
Yeah, so that's what I was saying. I'm gonna wait a couple of days, and I'm gonna give it another pass.
Awesome.
And then my last pass will be on Tuesday. So on Tuesday, I'm gonna go through all of them again and see who's resubmitted and all of that.
Awesome. Okay, yeah, I converted and I submitted them again, the 3 that were zeros for not being able to open.
Perfect.
Okay.
Thank you so much. See, that's perfect. That's exactly perfect, because see, now I can go through, like, people go like, oh my God, a 0, but it's not a bad thing. It's more like, hey, a reminder,
Okay.
All right,
Cool.
thank you.
Thank you
No
so
problem.
much. Have a great day.
Okay, we'll be here. I will be here Tuesday. Professor, see you.
Okay.
Bye-bye.
Good luck, everyone. Do your best.
Bye. Bye.
Is everybody out, Miss Diaz?
I think we still have one more person.
Okay.
Hassan, you had a question?
Siempre hace así, siempre queda el último, no. siempre se queda así, yo creo que deja abierta la página. Okay. Quería preguntarle, I just wanted to ask you in regards to the grades.
Yeah.
I was checking last night some of my my grade, and I got a little scared because I got 68.99% on my percentage. But I checked some of the assignments on like chapters reviews, and I have zeros. And for some of my homework, I don't have a grade. So I don't know if has to do with the final percentage. I don't know, because on assessment I have 87. It says, well, I wrote down the percentages.
Yeah.
In the course, I didn't do that good on coursework on Newton. In the beginning, I was just like, I didn't get it really, honestly. Yo creo que hasta la mitad del semestre. Oh, okay, no, this is part of the chapters I get. Well, I got that in the end, but on assignments, I got 85%. And I know the test, I haven't done that bad because I have been understanding the material since the beginning that you start explaining, the way you explain it, I guess it sticks on me.
Yeah.
But also the first quizzes, I understand that they were paper quizzes that we did in class, the first 3, I believe.
Yeah, so some of them are,
And so maybe I was thinking maybe that's why you didn't grade it, because I know it's more time.
Sí.
And yo sé que era más difícil para usted, so
Yeah, it was.
I don't know if it's, I don't know if I was going to ask if you please check that grade.
Yeah, for sure. You know, I don't know, like I seem to have misplaced a stack of papers. I don't know if those quizzes are in that paper. I'm just gonna subtract that from our total score. Like I'm not gonna count that towards your grade at all. That makes sense? So if that happens, and if a lot of people failed it, then that'll be beneficial for everyone.
Well, yeah, please check that, because
Sí, I have so much papers, de verdad.
No, yo sé que yo he hecho, like, I checked last night. I know I didn't submit homework number 5, and I did do it because I checked my my on OneDrive where I save all my assignments. And here, I don't know what happened. I just didn't submit it, but it's okay. Actually, I'm not gonna do it anymore because I know it's too much already. But I do, I just want to.
You could still do it. You could still do it.
Really?
Yeah, just do it. Like I said, just now it's like do it and turn it in. Resubmit it. Now's the time to resubmit everything to boost up your grade.
Okay, I'm gonna try to resubmit everything now. And I was thinking if you misplace those quizzes, the first quizzes, if you have them on Newton or on Canvas, I can resubmit it in el sistema instead of just forget about the paper.
Oh, I see.
I don't know if it's possible, or you just want me to just let it go.
Did you miss more than one quiz? Is that what happened?
No, I made them out. I did all the quizzes, and I have gotten good grades on all of them. But the first quizzes are the ones that I don't have a grade on, and I know those are the ones that we did in class.
Yeah, so let me go through all my tengo un montón de papeles, like a lot. I have a lot.
Mm-hmm.
But I have to get it all together anyways. Es que yo les digo todos oh yeah, Tuesday, pero la verdad que tengo más tiempo que ese Tuesday, I have more time. I just tell everybody that day, para que todos sean, y por si acaso, if I need more time, then I have more time,
Right. Okay, yeah, nomás eso, porque sí me preocupé mi grado, no puedes hacer hasta 3 horas haciendo tarea. It's like, I know I have to submit, except that one that I checked last night, homework 5, and okay, I didn't submit that, I guess. I missed it. I don't know, it happens.
Of course. Yeah, no, that's on me.
Es mucho lo que ha pasado, mucho lo que tiene uno que hacer, and I know